Today's video is going to cover the experimental setup section of the 620M user guide. We're going to follow this section and do a typical experiment using a mouse mesenteric artery mounted in the 620M chambers. We're going to mount the vessel on the jaws for small vessels as compared to the pins for the large rings. We're going to cover dissection of the tissue, mounting of the artery, normalization and wake-up protocol, as well as a typical experiment. For the purposes of today's video, we're going to dissect a first-order artery from the mesentery. The mesentery is a very good tissue bed to use for practice because it has many vessels of different sizes. You can see with the vessels pinned out that you have access and can easily view many different vessels. First, you need to clean away the excess tissue. You will clean down both sides, leaving the artery and the vein side by side. At this point, you will need to identify the artery. The artery has a thicker wall and a smaller lumen, which will make it appear more white. The vein will appear more red due to its thinner walls. If there is blood in the vessel, you will see the lighter artery and the more red vein. You want to avoid touching or cutting the artery with your scissors. You want as little stress as possible on the vessel. You can also place a ruler in your petri dish in order to get the exact length that you need for your experiment. This will help with the normalization steps. After dissection, we need to then mount the vessel in the 620M chambers. You will place a section of the wire between the jaws. You just need to clamp it in place. You do not need to press too hard, as you could damage the force transducer. Now on the micrometer side, you will need to secure one end of the wire. It does not matter which side. Place the wire under the screw and tighten the screw in a clockwise direction. Now you can add the vessel to the bath and fix your view on the free end of the wire in the bath. Now, using your forceps, you will mount the vessel onto the wire. Again, try to limit the handling of the vessel as much as possible. Slide the vessel up to the jaws. However, take note, if the back end is pinched shut, you do not want to overstretch the vessel too much by pulling on it. You will need to either use the end of the wire or your forceps to open the back side. Hold the free end of the wire with your forceps and close the jaws. Now you can open the jaws and place the vessel in the jaw gap. You can now secure the second side of the wire. Again, you will do this in a clockwise manner. Once you have this first wire secured, you need to ensure that no part of the vessel extends past the jaw separation on the outside. Move the jaws apart and grab a second wire. Hold it at least 10 millimeters from the tip. Carefully insert the second wire. You will need to avoid touching the lumen or letting go of the wire while it is still inside the vessel. Push the wire all the way through, or you can pull from the other side once you have the wire through the vessel. Pull it so it is equal on both sides. Move the jaws together and make sure that the second wire is under the first. Secure one end of the second wire, again in a clockwise manner. Pull and make sure that the second side is tight and secure the second end. You can now slightly open the gap and check that the wires are taut. Before moving back to the interface, move the wires so that they are almost touching side by side. After you've mounted your vessels in the chambers, you will bring the chambers back to the interface. And it's a good idea to start bubbling as soon as you put the chambers back in place. But once all of the chambers are in place that you'll be using for that day, you can turn on the heating. You can start your recording for the data acquisition. And we would recommend using the chamber covers that came with your system. So we will put those in place. This helps to keep the chambers and the tissue isolated. And then finally, before you wait for 20 minutes, we will do a washout with each of the chambers we are using. In this instance, we will be using chambers 1 and 2 today. After you've changed the bath, then you just have to wait 20 minutes for the chambers to reach their experimental temperatures. Normalization is an extremely important step in the experiment, and if not done properly, all of the data you collect will be invalid. We're not going to cover the normalization in depth. We have a normalization guide on our website, or you can contact a DMT representative to help find information on normalization. However, there are a few key points that we want to make. First, elastic preparations like these with vessels and especially arteries can only have meaning if the size is clearly defined. This defined size will change the sensitivity to agonists, so a standardized approach must be made. Lastly, the active response is dependent on the extent of the stretch of the smooth muscle cells. Therefore, you must set your vessel to an internal circumference that will give the maximal response. After these 20 minutes have passed and your chambers have reached the experimental temperatures, you can now start the normalization. Again, today we're going to use the DMT Normalization module on Lab Chart. So we click on the DMT and settings. Now these settings will be dependent on the type of vessel you are using. The first is Eyepiece Calibration, and we're going to use 1 so that we can type in the length of our vessel. Your target pressure will be dependent on your vessel type. And this IC1 to IC100 value, again, is dependent on your vessel type. And this must be done earlier to characterize the type of vessel you are using. Information on this can be found on the DMT Normalization Guide or through your representative. For mouse mesenterics, though, we're going to use an IC1 to IC100 value of 1. Now, typically, you will leave everything else the same. But for our video, I'm going to change the delay time from 60 to 30. So now we are ready to start the normalization, and we will be doing channels 1 and channels 2. So we saw in channel 1 that the vessel spanned the entire gap of the jaw. So we are going to set our tissue endpoints as 0 and 2. This will tell us that our tissue length is 2 millimeters. And we are using 40 micron diameter wire. And now we need to take a reading of the micrometer for channel 1. So we will take a reading. In this case, it is 2,230. And we will add that point. Now we have a 30-second delay on this one, so we can start with channel 2. Channel 2, again, span the entire gap of the jaw. So we will do 0 and 2 as our endpoints, which will tell us that our tissue length is 2 millimeters. Again, we are using 40 micron wire, so we will enter that. And now we will take a reading from channel 2's micrometer. So now we have our first point on channel 1. So now we can add our stretch and go on with the normalization. So in this instance, I'm going to add until I see, I'm going to increase the distance from the wires until I see a change in the force. So I'm slowly doing that. And now I will take a new reading. And since the second point is done, I can now go to channel 2 and do the same thing again. And now you see on channel 1, since that second point is done, we now have information on our graph. And after the next point, we will start to see our best fit line. So I'm just going to add 30 microns and let this go. And then I will do the same thing for channel 2. And after that, you will begin to see the line with the best fit curve. What we are trying to do is we are trying to just get over this target pressure line, which means that we have reached the target pressure point, which will give us our maximal responses. As you can see, though, we still have a ways to go, so I will add more to channel 1. In this case, I added 50 microns. And the same with channel 2. And you will repeat this until you reach your target pressure line. Now you don't want to go too far over that line if possible. You want to do your best to just go over it, over the top of the line. So we still have a ways to go again on channel 1, but we are getting closer. Channel 2 still has quite a ways to go. You need a minimum of 4 points in order to get an accurate reading, but typically you're going to end up with somewhere between 6 and 10 points. Again, remember, this is a best fit curve, so not all of your points are going to be right on the line. Now this one is very close, but it's still under the line, so we will do one more reading to get above that. And again, you can see in channel 2, we are close again, but not quite there. You will notice, while you're still below this line, you will see an extrapolated result under the best ideal micrometer setting. Once you have passed that line, as we have now, it no longer says extrapolated result, and it now tells you the point at which you should set your micrometer. So channel 1 suggests we set it to 2558, so we will get as close as we can to that number. And channel 2 has also passed it, and in this case, its reading is set to 2076. So we will move these back to those values. And now that you have done this, you can zero your chambers, your reading for chambers 1 and 2, and this is the point at which you are ready to move on and start the wake-up protocol. The purpose of the wake-up protocol is to get your vessel ready for the actual experiment. In order to do this, you need to reactivate the mechanical and functional properties of your vessel. You also need to check the responses to different types of stimuli to ensure that your vessel has not been damaged during the dissection or the mounting process. So the first actual step of the wake-up protocol is to add high potassium PSS and noradrenaline into your chambers. However, you want to make sure that you add comments throughout your entire experiment, even during the wake-up protocol, so you know what the stimulus was when you saw a response. In this instance, we're going to be doing KPSS, and it's going to be added to all the channels. And as you can see, we have contraction in both of the first 2 channels. We will let this go for 3 minutes and then do our washouts. For the sake of our video here, we will wash out a little early. and hopefully return back to baseline. So you will do 3 washouts over the course of 5 minutes, and then you can start the second exposure to KPSS and noradrenaline. After your washout, we will do a second exposure to KPSS and noradrenaline. And you will let this go for 5 minutes. Again, for the sake of the video, we will cut it a little short, but you can see a sustained contraction in channel 2 and a little less sustained in channel 1, but still a contraction. And you will wash out over 5 minutes. The next step of the wake-up protocol is using PSS and adding noradrenaline directly to the bath. So we will do that with channels 1 and 2. Again, we are using different stimuli to check different functions of the vessel. You will let this exposure go for 3 minutes and then begin the same washout 4 times with PSS over 5 minutes. As you can see, both have sustained contractions, and for the sake of the video, we will go ahead and start our washouts. And you will do this 3 more times over the remaining 5 minutes. Following this washout, you will do a 4th stimulus with just KPSS, and then a 5th stimulus with KPSS plus noradrenaline. Following each of these stimuli, you will do a washout period with 4 washes over 5 minutes. After this final wash, you are ready to begin your experiment. For a typical experiment, and any time you're working with a new vessel type, you will need to run a concentration curve to familiarize yourself with how the vessel will respond to the drugs you are giving. In our instance today, we're going to do a number of concentrations we're doing phenylephrine for this vessel. So we are doing our PE curve, and instead of doing the full curve, we're going to do an abbreviated one. So we will start with molar. We will be adding that to chambers 1 and 2. And it's suggested that we wait approximately 2 minutes between doses. We're starting to see just a little in each. And then we can move on to the next dose. And the bubbling in your chamber should be good enough to mix the concentration into the bath. You can see the higher responses in each channel. As you can see, it's still climbing in channel 2 as we approach our 2-minute mark. It is beginning to plateau right at the perfect time for our next concentration. And then we will go with our last 2 doses. And we'll go ahead and add our final concentration. As you can see, these vessels have pretty much plateaued in their response, which would then conclude our contractile concentration curve, followed by a relaxation concentration curve using acetylcholine, SNP, or any other relaxation agonist. For the final stage of the experiment, we're going to do a relaxation concentration curve using acetylcholine. So first we need to pre-constrict the vessels. And you're looking to get about 60% constriction, and you should know what this level should be based on the contractile concentration curve you just did. You're looking to get a plateau on each vessel, and then you can start your relaxation concentration curves. So now we can begin with our first concentration of acetylcholine. And again, we're waiting about 2 minutes for the response to plateau. Seems as both have plateaued. We'll move on. Vessel 2 seems to be responding a bit better than the first one. And then we will do our next concentration. We'll do our second to last concentration. We're starting to reach our peak relaxation, so we are seeing even less sensitivity to these higher concentrations. less response. And our final concentration of ACH, 10 micromolar. At this point, we have reached the end of our experiment, and you can proceed with the daily cleaning procedure that can be found in the cleaning and maintenance video and the cleaning and maintenance section of the user guide. For additional information, please refer to the 620M user manual or contact us through the DMT website where you can find additional resource videos.